Let's talk about solutions and solution energetics. So first of all, what happens when we dissolve something in solution, say water? So say we'll take a simple example of sodium chloride, and if we take sodium chloride and drop it in water, we know that it dissolves. So we have solid sodium chloride, we can't see it in solution, it disappears. But what is actually happening chemically? Well, what happens is the sodium and chlorine ions are held very tightly in the solid. In solution, the sodium and chloride ions separate and become surrounded with water molecules. I'm just going to draw a few waters here. But we have ion dipole interactions. The ion from the sodium plus, the dipole moment of water interact. So we have the negative end of the dipole of water pointing toward the positive charge of the sodium ion. So we have a sphere of water, a shell of water surrounding the sodium ion. So this is called a hydration shell or a hydration sphere. And so we have all these ion dipole interactions occurring, which are fairly strong. And so that enables sodium chloride ions to separate because of the energy released when we form these ion dipole interactions. And chlorine, in turn, will also be surrounded by water molecules, but the water will have the positive end of the dipole pointing toward the chlorine atom. So again, we have a chlorine ion surrounded by a hydration shell of water. So what about if we don't have an ionic compound dissolving in water? If we take table sugar, which is a molecular compound, we know it dissolves in water. So I'll represent sugar as these blocks. Now, table sugar is a solid, room temperature and pressure, and these sugar molecules are held together by dispersion and hydrogen bonding. These forces are fairly strong to hold the molecules together in the solid phase. But when we put sugar in solution, what happens is water forms a hydration shell around each sugar molecule, and so the individual molecules separate. And then we have water. Let's draw it as a squiggly line. So we have water surrounding the sugar molecules in solution. So this is what happens when substances dissolve in solution. So we have interactions between the solvent and the solute, which enables the solute itself to break apart. So energetically, we have three things happening. We have to break the solute interactions. So in sodium chloride, this would mean we have to separate the ions or sugar, we would have to separate them into separate sugar molecules. That's one step. The other step is we have to break up solvent-solvent interactions. Say in water, we have hydrogen bonding between water, so this is water. We have hydrogen bonding between the water molecules, and so we have to break apart the water molecules so that they can in turn surround the solute molecules. Then the third is to form solute-solvent interactions. And this is the hydration sphere that we were talking about. When water interacts with the solute after they're broken apart in solution to form the hydration spheres. So these three things energetically have to happen in order for something to dissolve in solution. It takes energy to break up, say, the ion-ion forces, or the dispersion and hydrogen bonding forces, say, between sugar molecules. So it takes energy to break apart the solute into its individual molecules or ions. And it takes energy to break apart the solvent. But when we reform interactions between the solute and solvent, this releases energy. So we have two steps that require energy, and the third step releases energy. So these are endothermic, the first two steps. And the last step is exothermic. So this requires energy, and this releases energy. So if we add up the energy required for each step, we can find the overall energy for the process. And this is what we call delta H for solution.